So now we're gonna use the idea of movements to now balance a beam, right? So in the last lecture, I told you basically I demonstrated by balancing my pen, right? My stylus. So now I would want you guys to just take a scale or a
सर
pencil.
आपकी वॉइस बहुत कम आ रही है वापस से.
Am I audible? Hello? Am I audible?
Yes, but very little.
Is am I audible clearly to everyone else? If my voice is loud and clear, give me a thumbs up. If my voice is loud and clear, give me a thumbs up. It is clear to everyone, Hamza. I guess use a headphone or increase the volume
Okay.
of your speaker. Yeah. Okay. So now I would just like you guys to take a scale or a pencil and try balancing it out. Right? Try balancing out your pencil. And if you're done, take a picture and send in the WhatsApp group. Jaldi se. Just take a pencil or you can open your camera and just show it to me. Okay. Either way, if you can open camera, just show it to me or just send a picture on the WhatsApp group. Take any instrument, a scale or a pencil, right? Try to balance it on your finger. Take a picture and give it, send it on the WhatsApp group. Or you can open your camera and just show it to me. Okay. Whatever suits you. So listen, I want you guys to basically now do some experiments and then realize, okay, what are we doing, right? You have 2 minutes to just balance it out, take a snap, or just open the camera to show it to me. Right? I'm waiting on the WhatsApp chat.
Sir, what? What do we have to do?
Yes, Hamza?
What do we have to do?
I'm just saying, okay, just take a pencil or a scale, try to balance the pencil or a scale on your finger, right? Okay, if you're able to balance it, you can say successfully, just send a picture on the WhatsApp group, or you can open the camera and just show it to me. Okay, I got the picture from Ruba. Ruba is able to balance the pen, and I got the snap over here, and also over here, Mashal also, right? Okay, okay. So Hamza जल्दी के भेजना रो. Okay, so now just try to think. Okay,
हो ही नहीं रहा, क्या करूं?
yes,
हो ही नहीं रहा बैलेंस.
करें. So now let's see. Okay, this is your finger, right? Let's see. This is the paper, right? Whatever object you have, let me just create the object using this, right? Okay, this is the object, right? So it had certain mass over here, right? It has certain mass over here. That is M1. It has certain mass over here, right? Let's say M2, right? You can assume this, okay, this mass is centered over here, right? Let's say I'm just going to assume a single point, right? जहाँ पे आपका mass sort of the entire mass of the scale is acting, right? So one force should be acting over here. Let's say if you're trying to balance out your object, it would flip sometimes over here. And let's say if you move your pivot position, it would move sometimes over here, right? Because these are forces over here. And this is the pivot center that was your finger, right? And this is the distance D1. And this is the distance D2, right? So you found a point that basically balanced out what? Some movements over here, right? So if this object moves in this direction, so this is called clockwise movement, right? If you see the clock moves in this direction, right? So this is called clockwise movement. And if your object is moving in this direction, so it is basically anti-clockwise movement. Right? So now we are combine movements to basically have an idea of how is it useful, right? It has a very practical application in, you can say, in industry, right? If you see, okay, if you see, have you seen? Let me show to you afterwards. Okay, afterwards. So this is basically balancing a beam idea over here. So you all did experiment जिसके अंदर आप लोगों ने, let's say you took a ruler, ठीक है, and you balance out your pen वगैरह. Okay. So now let's imagine this, right? Imagine this over here. Okay. So now हमने scale को basically center से fix कर दिया है. This is the fixed point over here, pivot, right? Taking the same idea which you had done in your basically picture. This is fixed over here. So this is a pivot, right? So object can either move in this direction, the scale, or in this direction, right? So now I'm going to place the masses in such a way that it is an equilibrium. It is not moving, it is balanced out. So now I will have two masses. Okay, one will produce basically anti-clockwise moment, right? One will produce clockwise moment in this direction, right? Okay. So now let me just find the clockwise moment, right? So I have mass 2. It would have weight 2, right? Some certain weight. So weight is equivalent to a force, right? We have seen that. And mass 1 would have certain weight also. Okay. That is going to be this. I'm going to call it weight 1, right? And you can see the distance which is perpendicular to the pivot is d1 for mass 1 and d2 for mass 2, right? So can anyone tell me how do I find moment in clockwise direction? I know the moment is equal to fd, right? What would be the formula of moment in clockwise direction? Which weight is causing the clockwise moment?
Gravity.
Nah. Which weight component is causing the clockwise moment? W1 or W2,
W2.
right? This is causing the object to move in clockwise direction, right? I'm going to take this particular force right now. So we're going to be W2, that is the force that is causing the clockwise moment, times the distance of this force from the pivot. That is distance to it. So therefore, you have the clockwise moment to be W2 D2, right? So now what about the moments in anti-clockwise direction? Which weight is causing the anti-clockwise motion moments? Which is
W1
W1, right?
into D1.
Yeah, right. So this is basically which you want to recognize. So it's going to be W1 into D1. Therefore, the moment which is causing anti-clockwise movement is going to be W1 D1, right? Now, what is the condition which we want to fulfill? That is, I want to balance out the scale, right? I want the scale to be balanced in equilibrium, right? So for that, we have principle of moments, right? So what is principle of moments? So this is basically states when a body is an object and when a body or object is in equilibrium, right? So what is important? The sum of clockwise moment about a point is equals to the sum of anti-clockwise moment about the same point, right? So there is no resultant moment which will cause the object to move. So the object will basically be stationary, and you can see the scale would be like this, which is going to be horizontal over here, right? Okay. So another way of saying this is all if you add the moments, it will basically add up to 0, right? Because a moment is basically in this direction, right? A moment is basically causing in this direction, right? So they're opposite to each other, right? Right? Does that make sense? So it will add up to 0. Okay. So now what was the experiment before? हमने basically we found these points D1 and D2 experimentally. ठीक है? वो कैसे किया था हम लोगों ने? So let's take this example over here. So to balance a beam about a pivot like the ruler figure this which is shown over here, the weights must be moved so that the clockwise turning effect equals the anti-clockwise turning effect, right? Which we have seen, right? So that the net moment becomes 0, right? What is the net moment? K. Let's take clockwise as positive and anti-clockwise as negative, right? So if you add, let's say plus 2 minus 2. So let's say plus 2 is the clockwise movement and minus 2 is your anti-clockwise movement. So net moment जो overall system पे apply हो रहा है would be 0, right? So now they're saying कि how do we balance out if the beam, which basically when you were balancing out your pen or a scale, so you did this, you basically did this part, right? If the beam tends to swing clockwise, M1 can be moved further, right? Let's say if it is moving, let's say in this direction, clockwise. So they are saying that you want to adjust the position of M2, M1, okay, to make it further apart, right? So it increases the turning effect, okay, because movement is equals to what? Movement equals to force into distance. And from the formula, you can see that movement is highly proportional to distance, right? So if you increase the distance of M1, it will increase the anti-clockwise movement because it was swinging in clockwise direction, right? It means that clockwise का movement ज़्यादा है compared to anti-clockwise. So you want to increase anti-clockwise movement so that you can increase it by increasing the distance, right? D1. So that is some trial and error method. And similarly, you can do arrange for M2 if it is moving for anti-clockwise. So you have done the experiment, you have learned how to balance out a pen or a scale. I guess Hamza se nahi hua. Hamza, you can try this after the class. You will find a point here, it will balance out, right? Yes,
Okay.
Hamza. Okay, no questions. So now, acha, if I write this formula down mathematically, what does that mean? It means case sum of and clockwise moment is equals to sum of anti-clockwise moment. Okay, so this symbol means sum of, and M subscript CW means moments, moment in clockwise direction, clockwise direction, and moment anti-clockwise means okay, moment in anti-clockwise direction. Okay, so if this formula is clear, kindly give me a thumbs up. Principal moments. We'll do example, which will make sense, right? Okay, it is clear to everyone. That's good. That's good. Okay. So now you have a question. So I want you guys to start solving this out. I'm just writing down the formula. So I'm going to give you 4 minutes for this. Okay. Since it is new to you. So that is moment of clockwise is equals to sum of moment of anti-clockwise. Right? So now I want you guys to find the value of basically W. Right. They are saying that the seesaw is now equilibrium. Right. It is basically in balance position. It is equilibrium. Right. So you can only apply this formula if it is in equilibrium, right? So now try to solve it out. And if you're done, raise your hand, okay? Okay, guys, I believe that everyone is done. Let's start solving this question, right? So it is a pretty important question which will help you solving your theoretical questions, right? And even MCQs. Okay. So let's start it out, right? So what is the first step which you should start with, right? That is the following. The first step is going to basically identify clockwise and anti-clockwise movement. Okay. That which component of forces are causing clockwise movement and which component of forces are causing anti-clockwise movement, right? And then you just want to apply. You want to apply what? The principle of moment. Right? That's it, right? These are the two easy steps over here. Okay, so this is the algorithm which you want to apply. So now let's see what components of forces are causing clockwise and what component of forces are causing anti-clockwise movement, right? So now let's mark it out over here. So you can see this is the pivot over here, right? So this component of force will cause the object, the lever, to oscillate in this direction, right? So just imagine this. Just imagine this. This is clockwise motion, right? And this is anti-clockwise motion, right? Just see your watch or clock and see how is the clock pen moving, right? pendulum moving. So it's moving in clockwise direction. That is why it is called clockwise, right? And even this 320 force is also going to cause the lever to move in anti-clockwise motion, right? So this is causing anti-clockwise motion. This is causing anti-clockwise motion, right? And this W weight is going to cause the motion of the lever in this direction, right? That is going to be clockwise, right? Now you identify the components. Now just simply apply this formula, right? This principle of moment formula. So now what is the formula says? It says sum of moments in clockwise direction is equals to sum of moments in anti-clockwise direction about the same point. What is the meaning of about the same point? It means that your pivot is same, right? So for this scenario, pivot is basically same, right? It is same. So for you're gonna find now the distances, right? For every couple of forces. So for 540 Newton, the distance which is perpendicular for 540 is this one, right? Which is given to you, which is one, right? It is forming an angle of 90 degrees. And for a force of 320 newtons, what is the distance which we will take? That is going to be this, right? From the force till the pivot. That is given to you as 3 meters, right? Okay. Similarly, for weight W, now take the distance that is going to be from the force till the pivot. That is going to be again 3 meters, right? Now you have everything. Just want to put it into the formula and get your answer, right? So you have only one clockwise moment vector, right? Which is only W. Only W is causing the movement in clockwise direction. The other two forces are causing the movements in anti-clockwise motion. Okay. So let's put in the formula. So therefore, we get the following that W into 3 equals to, right? So there is no other any clockwise moment creation over here. So we have just one component over here, right? Now we have one 540 and then 320 Newton, which is causing the anti-clockwise movement. So I'm gonna take this component, right? So 540 times 1, right, is going to produce an anti-clockwise motion. Plus, what else moment is there, right? You also have 320 Newton component, right? Which is causing the anti-clockwise motion. And the distance is 3 meters, right? So let's do this. You are summing up all of the basically moments, right? In anti-clockwise motion. 320 times 3, right? So this is the equation. Just want to simplify it. So it's going to be 3W, going to be 540 plus 320 times 3 is 960. And what is 960 plus 540? 14. It's 1500, right? And W equals to what? 1500 divided by 3. That is going to be 500, right? So your weight, your W force should be at least, but exactly 500 newtons to basically balance out your balance out the lever, right? So that is your answer, right? If your answers were matching with my answer, kindly give me a thumbs up. Okay, Masha's answer was matching, Vada's answer was matching, and Ryan also, Ruba also, Hamza also, Vada also. That's good. That's good. That's good. Okay. So I believe now you know the principle. Okay. So let me just give you one more question, right? Abhi, this is easy. Let me give you one more question to solve. Like you have a good practice, right? So now do this question, right? Practice question. Practice question. Okay. Hmm. Now you have pivot, right? And you have a lever, right? This is the center of the pivot. Let's imagine it's the center, right? So you have mass 1 here. You have mass 2 here. You have mass 3 over here. You have mass 4. And you have mass 5 here. Okay. Okay. Now this M5 became messy. This is mass 5, right? And let me just give you the readings. This is the center of the masses. This is the center of the masses. Center of the mass. Okay, so at this point, this let's imagine this is a ruler. This is a ruler scale, right? This is a ruler scale. Okay, so now I'm just giving you values over here. This is 10 centimeter. This is 30. This is 40. This is 60. This is 70. This is 98. So you're given the weights, right? You're given the masses. M1 is basically equals to M2, that is equals to 5 kg. And you're given M3 equals to M4, that is equals to 3 kg, right? Now you want to find M5 such that the scale is in equilibrium, right? It's a 6 mark question. So now I'm gonna give you a formula that sum of moment in clockwise direction equals to sum of moments in anti-clockwise direction. ठीक है जल्दी से करेंगे you have 4 minutes for this. It's pretty simple. You have the values of the distances, you have the values of their weights, you know the masses, you can find weights. We want to find the mass 5 such that the scale is in equilibrium, right? I don't know the mass 5. I can put any value of mass 5 just to basically gain equilibrium. Okay, so now let's find the distance, right? So the distance for mass 2 from the pivot is going to be 40 minus 30, that is going to be 10, right? It's in centimeters, right? So I want to convert it into meters. So this is going to be what? So this is 10 centimeter, right? Similarly, from here till here, this would be 40 minus 10, right? So 30 centimeter. And this is, let's say, D1. This is D2. Let's find D3. So what is the distance of the D mass 3 from the pivot? That is going to be 60 minus 40. So D3 is basically 20 centimeter. Right? Now your D4 is going to be 70 minus 40. That is going to be 30 centimeter. And the distance of the mass 4 from the pivot is going to be D4. That is 90 minus 40. That is 50 centimeter, right? Okay. So you now have all the values you have. You know what is the formula of weight. Okay. The weight is going to be mg, and you can take GS10, right? Or 9/8 depending upon your requirements. You want to take 10, right? So your weight is going to be what? It's going to be just 10 m, right? Just multiply the value of gravity with the mass. That is 10 m. Right? So now I'm going to create the equation, right? Let's create the equation. So what is the equation? That sum of clockwise moment is equals to sum of anti-clockwise moment. Right? Okay, before that
मेरा
I'm
वो
going to
क्वेश्चन ऐसे तो नहीं गया था, मेरा गलत है, मुझे समझ नहीं आ रहा है क्वेश्चन।
क्या हमजा क्या बोल रहा हूँ? Okay, I'm just solving it out over here. Let's I guess it will make sense, right? Okay, so let's convert the readings into meter, right? So how to convert from meter centimeter to meter, right? You know, okay, 1 meter is 100 centimeter, right? And if you go from centimeter to meter, you divide by 100, right? So that is equivalent to 0.3 meters, and this is equivalent to 0.1 meter, right? I'm going to highlight this using the highlighter, right? And this is equivalent to 0.2 meters. This is equivalent to 0.3 meters, and this is equivalent to 0.5 meters, right? Highlighting the values in meters. Okay, so now let's apply the formula. So what is the factor that is causing anti-clockwise moment? That is basically this. Weight 1 is causing and weight 2 is causing anti-clockwise moment, right? So the blue shows anti-clockwise, right? And let's say the green shows clockwise, right? Okay, so now this weight 3 is going to cause clockwise moment, this weight 4 is going to cause clockwise moment, and this weight 5 is also going to cause clockwise movement, right? So you have identified all of these movements direction, right? So now let's add on the equation over here, right? Okay, so let's add on the equation. Let me just save this out that way we can keep track of the progress. Okay, so clockwise क्या हमारे पास it is weight 3 4 5, right? So going to be W3 into D3 plus W4 into D4 plus W5 into D5, right? Equals to which one is which weights are causing anti-clockwise motion? That is W1 and W2, right? So it's going to be W1 D1 plus W2 D2. Now let's put in the values and let's see what do we get. So M3 and 4 are 3. So you can find the weight by basically multiplying the mass with gravitational force. Rating gravitational force is 10, right? So it's going to be as follows. So it's W3 क्या होगा मेरे पास? W3 is going to be, let me just work out over here. We'll work out the value of weights over here.
सर मास कहाँ से पता चलेगा?
अब तो मैंने मास दिया हुआ ना, ये क्या दिया आपने? This is the mass given to you, right?
अच्छा,
That was the question, no? Okay. So now let's find W3. What will be W3 is going to be mass 3 times 10, right? And mass 3 क्या थी हमारे पास? It was 3. Sorry, हाँ 3 था. So it's going to be, but 10 is on bucks. Sorry. It's going to be 30 newtons, right? So since mass हमारे पास 4 भी 3 kg है, so mass 4 का जो weight होगा वो भी 30 न्यूटन होगा, right? So you will also have W4 equals to 30 newtons. Okay. So now let's find W1 equals to W2, right? जो हम निकाल चुके हैं पहले से, ठीक है? जब निकालेंगे भी उसका बेसिकली वेट इज 5. सो दोनों की मासेस सेम है, दोनों का वेट भी सेम है. 5 into 10 is going to give you 15 minutes, right? So you get the following things now, okay? So W3 आपको पता है that is 30. And what is the distance 3? What is distance 3 over here? That is this, ठीक है? 0.2 times 0.2 plus W4. What is W4? W4 is same as W3, that is 30. And what is the distance 4 over here? Distance 4 कितना हमारे पास? It is 0.3 meter, right? ठीक है, let's keep W5 as W5 या known हमारे, ठीक है? What is distance 5 कितना हमारे पास? It is 0.5 meter, right? So times 0.5 equals to, what is W1? हम निकाल चुके हैं यहाँ पे 50 newtons, right? 50 times distance हमारा कितना हमारे पास? What is D1? The D1 is 0.3 meter, right? Over here. This is times 0.3 plus weight 2 is also same as weight 1, that's 50. What is distance 2? That is 0.1 meter, right? So let's simplify this. So what is 30 times 0.2? Can anyone tell me the answer? I don't have the calculator. So it's going to be 0.3 into 2. 0.6? No, it's going to be 6. It's going to be 2 upon 100. 2 upon 10 is going to be 6, right? 6. plus 3 upon 10 are going to be 9 plus,
9.
yeah, plus 0.5 W5 equals to what is 50 upon 0.3? 15, right? Plus 5. So you get what? What is 9 plus 6? 15, right? Plus 0.5 W5 equals to 20, right? So zero point 0.5 W5 equals to 20 minus 15, right? So let me add another slide. So you get zero point 0.5 W5 equals to 5, right? So now let's get the value of weight 5 of the mass 5. That is going to be 5 times 2, right? Because what is 0.5? 0.5 is 1 upon 2, right? So 2 multiplied by 11. So W5 is coming out to be 10 newtons, right? आपको निकालने क्या है? You want to find the mass of it, right? We know what is the formula of weight. Weight equals to, ठीक है, mass 5 times gravity, and we're taking gravity value as 10 meter per second square. So your mass 5 is going to be the weight 5 divided by the gravitational strength. It is going to be 10 upon 10. So your mass 5 is going to be 1 kilogram. Does that make sense?